Good afternoon, Aishwarya. Good afternoon, Shubham. Good afternoon. How are you guys? Doing good. Doing good. You can hear me, right? Good afternoon, Vishwajit. Good afternoon, Jashish. Good afternoon, everyone. Okay, so welcome, guys. Welcome. Yeah. Good afternoon, Adil. All of you can hear me, right? Why don't you guys join me on Discord? Okay. So, so I'll just give you a brief. Hello, Nitin. Hello. How are you? Danny. How are you? Jashish. Yeah. Good afternoon, Supriya. So first of all, welcome one and all. Hope you guys are doing well. And the first thing I would like to say before I start the session is stay safe, stay inside, stay isolated because we have heard like this thing is now increasing day by day. It's getting, it's the rate of spreading of this thing is faster. Anyway, so today I'll tell you presence. Shubham, present. Very good. Okay, you if you want to join me, you can join me on Discord. We can have conversation on this. Anyway, so today's topic will be module 3. This is module 3. Good afternoon, Vandana. Abhishek, good afternoon. Basically, uh, your both of the first two modules have been completed. It's just one chapter is remaining. That is called as cryptographic hash. So that I will discuss at some other point. And I have given assignment questions from that chapter, and the same questions repeats every time in the exams. So uh, I'll take that chapter up at some other point. But uh, Shweta, good afternoon, Shweta. Welcome, guys. So today's topic is your module 3, starting with module 3. And I would like to brief you about this module 3. It has 5 chapters, just like first module has 5 chapters. This also has a 5 chapters, this module, but these chapters are very small. So basically what are the contents in this particular module is about key management. Then you have concept related to authentication. So you will be having authentication 1, that is second chapter. Then you have authentication 2, you know, there's just the extension of it. Then you have security at network layer, and then you have security at transport layer. Okay, so we'll discuss all these things. You have heard about this HTTPS, you have heard about this IPsec, you have heard about this TLS. If you have not heard about it, we are going to discuss about that in this particular next I mean this particular model. So everyone has joined, right? Aditya, good afternoon. Hariharan, good afternoon. Fine. If you guys, again, I will repeat this. If you guys want to join in the chat, I mean audio, you can join my Discord channel. Anyway, so let's begin. Sanju, good afternoon. Okay, basically, what you need to know about before I start here is uh, key management. We saw Diffie-Hellman key exchange algorithm or protocol in the last class, and we saw the importance of this, securing these keys. These keys are nothing but your public key, private key pairs. Okay, so we have to secure. So this complete module is about how to manage these keys. So basically, what question you can expect is about certificate format and all, but we should know what is our concept of key management. So you can tell it's a very straightforward thing. Key management will be, how will you generate, store, distribute, and backup of key. When I say backup of key, it's like one copy of the keys is stored in the server, like a redundant copy. Now the focus of this key management is management of public key private key pairs, as I just said. Now where it is used, these public key private keys, they are used in encryption, decryption, also signature generation, verification, and authentication. Now we talked about the drawback in Diffie-Hellman key exchange algorithm. The drawback was basically, you remember the drawback in Diffie-Hellman, a man in the middle attack. So if two parties are not authenticating each other, there is a possibility of this attack. So how will we prevent that? We use the concept called as digital signature. We can use concept called as digital signature to provide authentication. Basically, what exactly is digital signature? It's like you are leaving your thumbprint or some prints, like you are signing on a document digitally. Digitally you are signing a document. So to do what? To authenticate yourself, like how faculty will stand up in the queue morning and evening while you guys are leaving out. You will make comments and all, but that's the thing, we will authenticate ourselves that we have logged in at this time and we have logged out at this time. So basically that thing done in digital manner is what your digital signature is, and that is used to provide your authentication. So if that is fine, we need to know, you know how does there's a question like, how does party A knows B's public key? So you remember in a public key cryptography, encryption is done by using recipient's public key, means B's public key, and decryption is done by B's private key. So how will A know about B's public key? There are three possibilities to it. Let's say A and B, they frequently communicate with each other. So what could happen? They frequently communicate with each other. So maybe in past B would have already given the key to A to communicate. They would have already communicated, right? So but what can happen if the attacker gets to know about the private key of the receiver or the second person B? He can decrypt that, the original message, right? If private key is compromised. Okay, so what other possibility can have? Let's say all the entities like A, B, C, let's say it's not A and B who's communicating, there are A to Z entities are communicating. Now they, let's say they all securely they maintain this all these keys in a secured manner in a centralized directory. So what can happen? They can maintain these keys in a secured centralized directory, but who will maintain that centralized directory? That itself is the issue. So for that, there's a third possibility which is valid throughout, which says A receives a document signed by a trusted source called as C here. Okay, this C, it contains what? It contains all the recipients. Let's say B, C, D, not C, C is let's say here. So D, E, F, and so on. Let's say this is a trusted party. It's a trusted third party who does what? Who you know stores all the public key of all the recipients. Okay, it's a trusted source. Okay, there's no compromisation of any leakage or anything from this. Fine, so that is clear from different scenarios. Okay, right. Any doubts until now? Please let me know. Fine. So what is a digital certificate? That's the also hold on. Okay, so what is a digital certificate? I just told digital, I told about digital signature, right? So what is a digital certificate? Another thing. So you can tell a digital certificate is a signed document. It's a signed document, electronically signed document, which binds a public key to the identity of a person. So this digital certificate is a signed document, electronic document that binds public key of the identity of a person. So let's say example, what example can we have is like an individual's identity. Identity could be his name, national identification number, email, address, employer ID, all those things, or combination of all those things. Then we have something else called as, you're clear with the digital signature, digital certificate, right? Another part thing is called as CA. CA is not chartered accountant. Okay, so CA here is another trusted entity. It's called as certification authority, or just simply certificate authority. So what is the role of this CA? It's the identity or authority that issues all these certificates. Okay, that issues all the certificates. Certificate authority. Now certificates can be issued to whom? It can be issued to individuals, organizations, even to servers. And when I talk about communication between A to B, it is not only one scenario where there's a one person communicating to another person. This scenario is same as when we are using our computer. We are starting our computer, we are browsing something, we are accessing some bank site. So we will say we are A and bank is B. Okay, that is also A to B communication. Good afternoon, Abhishek. How is everyone? Fine. Everyone is drinking water, right? Properly. Anyway, so as I said, certificate may be issued to individuals, organization, or even to servers. Now, so what is the basic scenario? How a person can apply to get this certificate? So most basic type of certificate may be applied through your regular email, with the applicant has to state their public key, their name, email address, etc. Okay, so basically CA, this certificate authority, it does not require any more credentials on the applicant, but to perform some more checks, security checks. So what it can do, certification authority, this certification authority, to perform security checks on the, if it is a genuine applicant or not. So it can, you know perform some identity verification on the applicants. It can perform identity sorry identity verification of the applicant by using some other mechanism, like CA sometimes makes use of or takes help of something called as registration authority. Let's say uh, CA is nothing but a central government, RA is nothing but your state government. So central government will assign some work to state government and they will do the task, and then again they will report back to CA, just like that here. Okay, fine. So that's about the certification types, the basic introduction. Now the assignment question that I have given was, explain this X.509 digital certificate format. So what exactly is that? Basically this question repeats every time, so I'll just show you the diagram of it. You have to draw the diagram and talk about the six fields of this. There are six fields to it. Okay, if you see the diagram here, there are more number of fields, but how will you divide that in six fields? So first of all, X.509, it's so what you should have no confusion with these terms. What is a digital certificate or digital signature, certification authority, registration authority? Anyway, so X.509 or X.509, it's a standard digital certificate format standardized by your global thing called as International Telecommunication Union, ITU. So it specifies what it does. This global organization, it specifies format for your public key certificates, for your public key certificates, because we are when you're talking about keys here, it's a public key private key pair. Okay, so what are the fields of this? If you see the diagram here, there is 6 fields. First of all, let me divide it as first field as certificate, serial number, and version as one. Serial number and version, certificate, serial number. So each certificate that is issued by given certification authority will have a unique number. This it's a unique to every certificate. Each certificate it's unique. Next thing what you have is the issuer's information. The certification issued by the organization, whoever is issuing that information is included here. Okay, like it can include email, it can include organization, country name, all those things. So next thing, third you have here is certificate, signature, and associated signing algorithm information. So associated signing algorithm, some algorithm will be used, right, to perform some algorithm will be done in the certificate itself. And what else? This and certificate signature, you read about it. And one more thing, these notes, all the notes, there are 4 types of notes I have. This PPTs, these handwritten notes also, internet notes, the notes which were available on the DigiNotes and all, and the notes which I have provided. So all 4 kind of notes are available in the classroom group, Google Classroom group. I have shared in the drive. You anytime at any point of time you can just check the content and you can read about it. That's also fine. Anyway, so it third is certificate, signature, and whatever the algorithm is used to sign that certificate. So fourth is your, it's a very easy one, is your validity period. So what it means to say, every certificate is valid from starting date to the ending date. Let's start from yesterday, so it ends tomorrow. After that the certificate is invalid, even if the person says I have authenticated, I'm authorized, but the certificate will be invalid. Fifth, you have here is subject information. Subject information. So basically, uh, I will like to give you an example for that. So a different name of the certificate subject or a owner. For example, let's say if a customer is there and its intention is to communicate with the e-commerce. Let's say we all are having in a situation like we want home delivery of daily food and beverage, not beverages, food and this daily essentials. So we'll go to this e-commerce website like Grofers or something else. So let's say we have gone there. I'm calling it as e-mart, some e-commerce called as e-mart. Okay, so so what happens, customers browser will request for bmart's certificate. Okay, so what is there in the client side? Client side software is nothing but your browser will check whether this the common name in the emart certificate tallies with the emart domain name. Okay, and other information such as subjects, country, state, organization, that also can be included. So that is about your subject information, the subject. Now last we have is subjects public key information. Okay, I'm writing it very illegible manner, not visible, I know, but you can read about it. It's there in the previous slide, all these things whatever I'm writing here. So no worries. So what is that? Subject not PUBG, sorry, public key information. It includes public key, public key algorithm. What are the public key algorithm? Can you name some? RSA. RSA is your public key algorithm, right? And the public key parameters. Okay, so parameters might include like how exchange of keys are done, like let's say Diffie-Hellman. Okay, fine. So this is the diagram for X.509. This question is asked most of the times for 8 marks. So you have to, even in the assignment question I have given this, so you write the about this and some details about it. Okay, so next thing is digital certificate in action. In action, how it works actually. So let's assume that there's a party A, it needs to securely transmit a session key to B. A needs to securely transmit a session key to B. So what it does, it will obviously encrypt something, right? Encrypt with what? Using B's public key. That is how encryption is done in public key cryptography. Now A also needs to retrieve the public key from B's certificate, right? How will A know about B's public key? Because they can know about it by looking at the B's certificate, right? Who will now you understand how A will get the B's public key by looking at the certificate which is given by the trusted parties like certification authorities, CA. Now, so there are some checks as is mentioned here. If a person obtains other person's certificate from B, let's say if B is actually genuine person or not, so it needs to perform some certain checks. What are the checks? Identity check, validity check, like if it is valid, even though if it is correct, if it is it valid, the certificate is valid. It's just like the key is not for the lifetime, it's only for the some time period. And signature of, if the concerned CA or RA has actually approved that, then only it's true. Okay, so then you have something called as public key infrastructure, right? So what it includes, overall architecture, overall infrastructure. It includes, let me erase this part is over. You have understood about X.509 certificate. It's a direct question, sometimes asked, not sometimes, most of the times. Okay, so we talk about public key infrastructure or PKI. So it's a let's say a bigger thing. So it includes CA. It includes, the CA is included inside this infrastructure. Also, it can include like another infrastructure called as something like the encryption or encryption decryption techniques, the techniques or hardware. It's a complete infrastructure, right? So it includes everything. And also you can tell some policies or procedures. So five things, these five things PKI consist of, these five things. What are those? CA, encryption decryption technologies, hardware, formulation of policies, procedures, and so on. Now what are the functions? What is the use of this PKI? So it does these functions, what you can tell, you can just name them. So certificate creation, now after creation issue it to the concerned person, storage and archival. Once it is sent to the concerned person should be, it should not be very complex for him to actually use it. That's a safe archival. Also there is another function called as key generation, key escrow, certificate or key updation, and certificate revocation. Okay, so that's about it. Now this is like a question asked, explain about PKI architecture. So there are four architecture here. If you look here closely, you can see four architectures. So I'll just tell you in the brief how it works. There are first one is a very simple one, a public key infrastructure with a single CA. There's a one okay, you can see the diagram itself. There is one certification authority and there are different users, U1, U2 to UN, right? You can see that, right? Fine. So at any point of time there will be multiple users but only one CA. For example, let's say certificate from CA1 to, okay, let's say uh, this is CA1. This is user 1, user 2, user 3, user 4, user n. At any point of time, certification authority can serve two parties, U1 or U2, U1 or U4, or U1 or U3. At any point of time, only one. So that's a limitation with this particular scenario, because there's only one certificate authority. It can serve only two parties. Once they are finished with all those communication, moves to the next request. That's the scenario here. Okay. So next we have is a hierarchical or tree based, hierarchical and or tree based PKI architecture. Here you can see the diagram here. Look closely into the diagram. I will give you a scenario. Let's say user 1. User 1 is right here. I don't know if you can see this. I don't know if my cursor is visible here. Okay. Capture cursor. Yeah. Anyway, user 1. This is user 1 here. Just right below CA2. Okay. So it wants to, it needs user 5 is public. User 5 is where exactly? User 5 is right here under CA6. User 1 is under CA2, whereas user 5 is under CA6. Now how how hierarchy works here. So certificate signed by CA1, it asks for CA3's public key. So CA3, certificate signed by CA3 will ask for CA6 public key, and CA6 certificate signed by CA6 will ask for user 5's public key. So basically how it works in terms of what do you call it as uh, how this torrent thing works, peer to peer. Fine. Next thing is we have here is mesh based PKI. So see the diagram here, mesh based. We know how mesh network works. Similarly, this also works. You can just give example. If two users wants to interact with each other, how it works. It can use mesh work. It can use, if there's one path is not available, use the next or nearest feasible path. That's how it is actually. Then this is the next one is bridge based. So basically, if you see the diagram here, this is a little different. There is like a bridge between two different CA. There is a representative CA for one PKI. There is another CA for another. Okay. Once again, there is a two different CA for both organization A and B, and there is a bridge CA. Okay. At the top, there's a bridge CA. So they have to communicate through this bridge. That's how it is. Just write about it. It's nothing complex. And next thing is, so this is a last topic here actually in today's class is a certificate revocation. Okay, so what exactly it means revocation? Let's say validity period of our X.509 certificate, okay, is always contained in the certificate, right? But there are other reasons why this valid certificate may actually be invalid. The certificate may actually become outdated or invalid. So what are the scenarios? There are two scenarios. When a person loses his authorization to use the key but still uses, let's say one has the authorization, but sorry, one loses the authorization but he has the key, and still uses it, or it cannot access that. It's not for him anymore. And another scenario is when the private key is compromised at any different levels. So that's about it. Certification revocation scenarios. So how do you, okay, How do you recover from this anomalies? That is called as handling revocation. You can get the question as what are the scenarios of revocation and how do you handle this revocation. So first solution is uh, you know uh, to use a online facility that provides information on the current status of digital certificates. So what we have, for that we have a protocol called as online certificate status protocol, OCSP. Only this much you have to mention. Then another scenario is another proposed solution. Okay, so we have something called as a list of all the revoked certificates, certificate revocation list, CRLs. So these if these CRLs are distributed too frequently, they could consume a lot of bandwidth. Okay, if they are distributed not so frequently, information on recently revoked certificate may not reach to those who in the those who are needed in the time in a timely fashion. That is also a scenario here. Solution 3 for handling revocation is by making use of some other trusted third party. Here we call it as trusted third party as TTP, trusted third party TTP. So for example, for that is a Bone04, some different organization. So basically that's all for this particular chapter. This thing is there, identity based encryption, but okay, but it's not that important. It's not been asked much of the a lot of times, but you can read about this identity based encryption. You have to read an example. It's a case study kind of thing. You have to tell by giving an example how it is working. Basically, you know uh, what do you call as verification of someone's identity, and you have to give an example for that complete process. If A wants to communicate with B, first A has to be identified, authenticated, all those things. Okay, so that's all about this particular session. And if you had any doubts in this particular session, you can ask me now. So that's all for this stream or this session. It's a short session itself, so I will have to keep all these session for this particular only for this much time, not too long. And that's all for this session. We'll talk about the next chapter in the next stream, that is your authentication 1. So that's all from my side today. And if you want to add something, few things, please let me know. These notes are available, not only these PPTs are available in the group, classroom group. And please make sure you hit the like, guys, before you leave. You hit the like on the video, and if you have not subscribed, you subscribe to that. And if at all there is some issue with this, like you have not understood, you can just come back again, watch the video again here, because it's always available right here. It's stored here. It's not like how it is in Google Meet. The video is not available, I guess, but here it's available. So make sure you hit the like and share it. If you want to, some friend would have missed that, you can share it to them. So I hope the session was good for you guys. And I don't know if this is actually your lunch time, right? So thank you for coming during your lunch time, and I'll see you the next session. I will give you one more survey form. Please fill it. That's very much required. And thank you, guys. Hope you have a wonderful day ahead, and stay safe, stay protected, stay isolated. Okay, guys. Thank you so much. Goodbye. Bye bye.